Hi guys, and welcome to a new tutorial of Blender and Geometry Nodes. Today we are going to learn how to create a group node that you can use to instantiate your collection of objects along a curve and in detail along corners of your curves. So let's get started. I'm using Blender version 3.3.1. Go to plus menu, general, geometry nodes, and we are going to add a bezier curve. Press 7, tap to enter in edit mode, and we are going to subdivide this curve sometimes. G to move, press Ctrl to snap to the grid. I rotate this a little bit, I rotate this a little bit, select this point, S to increase these angles here and here. Press A to select all, subdivide 1, 2, 3 times, for example. Now click new to add a new geometry modifier. First of all, we have to resample our curve. It's useful using the length in this case because I can have a curve that can change in the space. I press Ctrl G to create my new group node. I don't want the selection attribute, so press N, go to group, selection and minus. The length is correct. Then I want to set the spline type to poly for this purpose. Select this button to snap to the grid and then press tab to exit from the edit mode of this curve. And what we want is the ability to instance some object along the curve and to be able to scale these instances, offset these instances and filter their visibility, like so. We will add some parameters like normalized, etc. So we need to save, to store an attribute that is the original normal information, because then we will change this normal information during the offset along this new curve, and maybe you want to reuse the original normal for the new generated instances and not the new normal of this curve. So in this case I needed to link these to this store name attribute here, and we can call original normals. Select these nodes, Ctrl J, F2, save original normals. Now the tricky part, we want to calculate the angles along this curve. How to calculate these angles is not so hard. You have to know that if I have a point here and a point here and here and here, we want to save on each point the angle that each point has with the other two angles, one next and one previous. So to do this, we have to calculate this vector from an index and index plus 1 and index minus 1. So we want this vector and this vector. To calculate these two vectors, imagine that you have here the origin point of this coordinate system, and you have this point, and this point. So to calculate these, we need to subtract from this vector, vector 1, this vector. So you know that the position of this index plus 1 is this point, so the vector 1. For this index the position is this, so I want to do vector 1 minus vector 2. Then we have to subtract from vector 2 the vector 3, and because we know that the dot product is equal to the module of one vector per module of b vector per cosine of alpha, so the angle between these two vectors, we know that we want the alpha, so the angle between these two vectors. So imagine that for these two vectors in these two directions, I will not have this angle, but you have to imagine that I want this angle because the direction of this vector is this, and in our case we want a more offset along the normal if I have more angle between these two vectors. And you can see that with this vector here and this vector here, the angle is smaller. So I want small offset here, and then more offset here, and then small offset here. Now we can simplify this formula because we can normalize these two vectors to get for both of these values 1 and 1. So the multiplication between these two values is 1. So the dot product is equal at this moment to 1 per 1 cosine the alpha, so is equal to cosine the alpha. And from this, if we calculate this dot product between these two vectors, I can calculate the alpha as the r cosine of the dot product, and this is what we will do. So first of all, we need to calculate these two vectors. To do this, I need a transfer attribute 3 times, one for the index plus 1, one for the index itself, and one for the index minus 1. For these 3 attributes, I want a vector, and I want the position of these points, so I need to use this geometry. For these nodes, I can link this position with the Alt and right button to all these 3 nodes. Then I want the index here, and I want to select the index selection here because we have no mesh, so no near to face or interpolation. And I want here the single index. Here I want to subtract 1 to this index and link this output here. And here I want to add 1 and get the index here. Now that we have the position for each index of the index itself, index plus 1 and index minus 1, we want to calculate these vectors. So we need to do these 2 equations. So vector 1 subtract vector 2 and vector 2 minus vector 3. From these, we need to normalize these vectors here and here. We need to calculate the dot product of these vectors to have the cosine of alpha, and we have to calculate the arc cosine of these values to have the radians of these angles. Now that we have all these nodes, we can select these, Ctrl G to create a group, tab to exit from this node, we can call it calculate angles, tab to enter. Now enter in the group node, we want to export the arc cosine for now in the group output, I can call it angles, tab to exit from these, and we can store this information in this geometry or in this original geometry. So I can link these and call it angles. Now I want to show you a little problem because we have a curve that I don't know if it is cyclic or not. So you can see the position of the index minus 1 is correct in this case because we haven't other index here, but in the case where we have a curve that is cyclic, this could be a problem. So imagine that you have a circle like this or an arc like this, and this is cyclic. If this point has 0 index, I want the next vector, but I want to get the vector from the last point of the curve here, get the correct angles between these 2 points and these 2 vectors. So to do this, I need more nodes here, so I can ask if is cyclic my curves, and keep in mind that in this case the cyclic is always false if you have these poly. So I decided to leave these 2 poly. So if you want to change these to Bezier, you know that in that case is cyclic can be true. Now we can add a switch and we can say if the index subtract 1 is less than 0, so the minimum index that we can have, I link this to the switch, and if it is true, if this is cyclic, I want the maximum spline length here, so the point count, so the total points minus 1, because I want the last index, and this is the count. So because the curve starts from 0, I want the point count minus 1. If it is cyclic, I want these values, otherwise I want 0, so the same start index. So in this case I would have 0 index here and 0 index here, and in that case I would have here a number minus the same number, so 0, normalized is 0, and the dot product, as we saw here, would be 0, and we will make tension here for the arccosine result, because the arccosine of 0 is not 0, but pi divided by 2. Now, if the index minus 1 is less than 0, I want this result, otherwise I want the index itself, so the index minus 1. I collapse these and I can link these to the index. Now this is the workflow, and the same approach here, so we can select these nodes, Shift D to duplicate them, and if the index plus 1, we can choose equal, for example. So if the index plus 1 is equal to the point count itself, because if we have 17 points, we start from 0 to 16. So if I have the index plus 1, 17, I have a number over the total counts of the points of the curve. So in this case, if it is equal, I want to ask me if I have a cyclic, and if I have a cyclic, I want the 0 index, so the first index of the curve. Otherwise, we need the point count minus 1, okay, or the index itself, because this is the last index we can have on the curve. But for symmetry of layout, I will link these to these false of this switch. I can set these here, and in this case, if the index plus 1 is not equal to the total point count, I have to maintain the same value for the output of this index. So I can create a dot here, collapse this switch, this, and move these nodes a little bit. Perfect. Now to see the values, we need to press tab to exit from this subgroup node, and tab another time selecting this group input to link the original geometry here, and we can join them together to see the result, and we can call this big node group corner instance here. Perfect. Now enter in this node, we can shift control click and shift control click on the arcosine to see the total result here. Perfect. We can see the total arcosine of this curve, and you can see the curve itself, and you can see for the 0 values here we have an height number. So for this point and this point, if I go to the last number, I have a big number here. So we need to avoid these bad values. So to fix these, we know that the dot product is 0. So if I press shift control click, we have 0 here, and for this we can say if the dot product is equal to 0, with 0 as the epsilon, I can add a switch here to have an integer number, and if it is true, I want 0. Otherwise I want to multiply by 1, and I want to multiply this arcosine with this switch to get a correct result. And now if I link these to these values, you can see I have no 1.5 etc, but 0, because the dot product of this first index and the last index is 0, and the switch give me 0 in this result, otherwise 1. So if I press shift control and click, I have 1 for almost all the indices, but for the first and the last I have 0. Now I can cut these, I can select this node, Ctrl J, F2, avoid bad values on start, and now press tab to exit from this node, select these two nodes, Ctrl J, F2, save angles. Now you can see that for all these vectors I have always a positive number. For the angles, if I press shift control and click, you can see these new column in the control points here, and there are only positive number because the angles between two vectors in this case can have values between 0 and pi, so 0 degrees and 180 degrees. So if I have two vectors like these, I have 0 degrees, but if I have a vector like this, I have 180 degrees, so the maximum value that I can have in this case. Now we need to calculate the influence of this angle along the normal of these curves, so we can get these new angles variable, and we need to multiply this value by what? By the normal of our curve. So we need to scale the normal of each point of this curve. So if the normal is this, I want a big normal here, and a small normal here, and a big normal here, etc., depending on these angles value. So I can multiply these by these, select all these nodes, Ctrl J, F2, calculate angle influence. Now we can decide to normalize this offsetting along this curve. So imagine that you don't want to have the new point here to instance the object that you want, but you want a normalized offset for all these curves. So to have this new configuration, we need to add a new attribute in this group node that we can call normalized offset. It's a Boolean attribute. We can use a switch node here with the group input node here, and we can say if the normalized offset is turned on, I want this scaled but normalized, so I can select this and link this to this, or have the original scale, so the orange offset that you can see in this simulation. And because I see that the normal of these curves go inside these curves, I will add a math vector here with the scale values of -1 and link this result here and this to this and this result here to have the correct direction in the out direction of this curve. I can select all these nodes, Ctrl J F2, normalize offset. Now I can play with the offset itself, so I can easily add a new attribute offset that is a float value, add a group input node here, and we can scale this another time with this new value here, and we can use this to set the position of the geometry with this new offset calculated. Ctrl H, we can select all these nodes, Ctrl J, F2, offset, we can insert this frame, perfect. Now we have the offset. Now we can start to instantiate a collection of objects, so I will create a new collection of objects. I can drag these into my workflow. I can add a mesh like a cone, for example, scale it a little bit, and keep in mind that you need to align the mesh on the origin to have the origin point in the bottom part of this object. So I can press Ctrl dot, select the snap tool to vertex, G, Z, and press Ctrl to align to this point the origin of this object, Ctrl dot to exit from the origin point or decheck this check, Alt G to reset the position, the location of the object here, Ctrl A and apply the scale. This is very important. Now I can select my Bezier curve, press 7, press home to view the entire geometry nodes layout, enter with the tab in this, and instead of using directly this collection, we can add the group input here, add the collection out, we can rename it in objects, move up. Here we can add an instance on point here when we want to instance our geometry, and we need to select this check, and we can export the instance index, so you can randomize the selection of all the objects in this collection or follow the sequence you have in this outliner. Select this attribute, move up a little bit, tab to exit, and we can use the index, for example, to set this sequence, tab to enter in this, select separated children and reset children for security reason, and select relative. Now you can select all these nodes, Ctrl J, F2, instantiate collection. Now we need to rotate these instances along the normal, and for this you can choose if you want the original normal or the normal changed by the offset along the normal. So if I press tab and increase the normal, you can see this effect. So I have this instance that goes out this, and for this new curve I have new normals here and not the original normals. So we can add a new Boolean attribute that we can call use original normal, and here we can add a group input node. We can move up a little bit this new attribute, and we can add switch where we want a vector, and if I want to use the original normal, I have to get the name attribute of the original normals here. Otherwise, I want to use the new normal of the set position node here. Okay, now I can collapse this node, Ctrl H. Now I can use this output vector in an align Euler 2 vector because I want to align the z axis of my object, the cone or other object in this collection. So I want to align the z axis to a new vector. What a vector? The normal of this curve, and use this for the rotation of my instance. Now you can see the direction is in an opposite direction in this case. We can select all these nodes, Ctrl J, F2, rotation, and now don't be afraid for this result because we will adjust this with the scale factor, but the direction is correct. Now that we have the rotation, we need to adjust two things. One is the scaling of these instances, and one is this factor, this problem. So in this case, you can see the values of the direction of the offset is always to the same direction, and we need a value that can multiply by -1 this offset direction. So we want to go in this direction. So to fix this problem, I need to go here in the calculate angle influence. So we have here the normal, the scaling about the angles, but I need another variable that can flip these normals to this direction. So to do this, I need to create a similar layout like the calculation of the angles. So I can enter in this workflow, select all these nodes, Ctrl C, Tab, Ctrl V to paste this workflow. We don't need all these nodes, but we want only 2 nodes. Why? I explain. If I want to flip the direction of this normal and want to get the convex or concave information, I need to get the tangent information of all these points. So for this point I have this tangent, for this point I have this tangent, for this tangent, for this tangent, and so on. And what we are going to do is calculate the difference between these two tangent, and you can see the direction of these vectors. This tangent now is here, this tangent now is here, and this is here. And next we want to calculate the dot product between these normals and these new vectors. So making the dot product between these two vectors, so these with these with these, and these with these, will get a number that we can use with the sign mathematical operation to get plus or minus sign to multiply to our angle influence. So we need only 2 information, not the position but the curve tangent information of the single index of the index is itself, and the index subtract 1, so the previous index for each point. So I will do this vector minus this vector minus this vector, and this vector minus this vector. So I can delete these, all these nodes, these. We can link the original geometry here to this point. You can select all these nodes here, and as described before, after the subtract value we need to get the normal information here, and we have to do a dot product with this new result, and from this dot product we need the sign of mathematical operation. And you can see if I press Ctrl Shift click and Ctrl Shift click, you can see we have for these 2 points -1, then we have 1 for all these points until this part of the curve, where we have the opposite sign for all these curve until the end. So now that we have this sign, we can multiply these values of the angles by this sign and then use this result in the scale, and this is the correct result. Now we have the correct offset along this curve, but we need to adjust the scaling and the sign of the scaling of these entire instances. So I can collapse these nodes, select all these nodes, Ctrl J, F2, get sign from concave or convex info. Now for the last part we need to change the scaling of these instances, and to do this we can easily link the multiply value of the calculate angle influence to the scale of the instance on point. But not only this, we could add a new attribute here, a float number, as the scale, and we can use a new group input here, a new attribute if we want to normalize the scaling of all the instances. So I don't want the scale depending on the offset on the curve, but I want all the scale equal to 1. So I can add here a boolean normalize scale. We can move up a little bit, and we can use these two new attributes in this way. We can add a switch node where I want a float value and a math node, and if I want to normalize the scale, I want the original multiply calculation of this angle influence. I want to calculate the sign of this because I want to maintain this sign even I normalize the scale. So if I have the normalized scale, I want only 1, 0 or -1 as the total scale of my instances. So these three values are the only values that I can get from these values from this part, and not the values itself with digit or other. I want only the sign, otherwise I want the original value. So from this direction I have infinite number, so 0.268 for example, or -0.1, and from this output I have only three values, 0, -1 and 1. Now I can collapse these and multiply this result by the scale that we have here in the new attribute. Ctrl H, G to move. This is the scaling. Now I can link this value to the scale. Tab to exit. I can set the scale in this direction or the other direction if I want. I can normalize the scale, and you can see all the instances have the same scale, but in my opinion it's more cool this not normalize scale. And there is a problem. Now if I change the length, you can see the scale of your instances changes. So I don't want that. You can see that if I increase the length I have more scale. If I decrease the length I have a smaller scale. So this is telling me that I can get the length information, and I can divide this output of this multiply by the length. Ctrl H. In this way, if I press tab to exit from this group node, if I increase a little bit the scale here and I change the length, you can see nothing change in the scale of the instances because I have a relationship between the length and the scale of the instances. Now I can select all these nodes, Ctrl J F2, scale, and for the final part I want to filter only some points on this curve to be instantiated, so I have to decide what selection to have here, and to do this I can get the angles that I have, I can add in the group input two parameters. One is filter from 0 to 1, so 0 the filter is deactivated, and 1 I want to filter all the points out, and a boolean parameter that I can call filter inverted. Now I can add a group input here, and I can remap with a map range what the minimum and the maximum values of the angles that I have here. So I can use the attribute statistic to get the minimum and the maximum values of this angle, and remap these from min and max to 0 and 1, because I have the filter attribute from 0 and 1. Link the attribute of these angles in this map range. Ctrl H to hide the other attributes that we are not using here. And now if the result of this map range is less or equal, or is greater than or equal to my filter, so I can link here these, and I can link the result here and the same filter here. I have these, the opposite selection, if I want to use the filter inverted attribute. Now I can add a switch node with a boolean, and if the filter is inverted. For example, I want the less and otherwise I want to greater, or the opposite. It's the same approach. Control H, perfect. And now we can link this switch output to the selection of the instance on point. Select all these nodes, Ctrl J, F2, filter. We can create a new mesh here. I can create an icosphere, for example, scale it, Ctrl A, apply the scale. This is very important. We can hide the object of the collection. We can select the curve, and now we can play with our parameters. I can increase the filter or decide to have the filter inverted, scale the instance as I want, offset as I want, decrease or increase the number of my instances. For example, I can enter in the edit mode of the cone, scale, shift Z, and I can decrease these. I can select the icosphere, G and Z. I can move it a little bit up, and you can see the icosphere is still in the wrong position because you are able to enter in these nodes and choose if you want to reset the children or not. If you don't reset the children, you will use the origin point of the coordinate system. If you reset the children, you will use the center of the origin of each piece of this collection. So in this case, the origin is here, so we have here an offset of this radius. Okay, you are free to choose what parameter you want in your group node. You can customize depending on your purpose. If you want to leave the reset children turned on, you need to select your object, activate the origin, easily move your origin point from this center to the origin of the coordinate system, for example, or move it where you want in the 3D space. After that, disable this origin, and for example, I can also select with the right button, set origin to 3D cursor, and this is fixed. And if you want all these objects of this collection instantiated on each point of this curve, you can enter in the group node and deselect separate children, so the entire sequence of these meshes will be used as an only instance to instantiate on each point of this curve. Another important information: if you select this curve and you press O to enable the follow proportional editing, if you press G and Z, for example, and create this particular effect, remember that you can manipulate the tilting of each point of this curve to manipulate the direction of the normal of these lines. So if I press A to select all these points, N, item, you can see that if I increase this mean tilt, I change the normal of all these points. And this is important if you have a curve that need these little adjustments. Now you can see here, I can use the original offset, so the offset of the original curve. If I want to offset more or less, I can normalize the offset, so in this case I can have this effect distributed on the curve. This, for example, if you want to have a guardrail for a road, or if you are making a bracelet, for example, and other stuff. And this is the tutorial. Thank you guys for watching this video. I hope you like it. You can download this project from my Gumroad page or create this workflow from your own. If you like what I'm doing, please subscribe to my channel and check the bell icon to get all the notification about new videos. If you want, check like or leave a comment, and see you in the next tutorial of Geometry Nodes and Blender. Bye!